let's get started here. I'm going to start with questions from homeworks. So at this point, we've assigned worksheets 1, 2, and 4, as well as 1 through 16 from the problems, and the Delta Math. Well, in fairness, the worksheets 1 and 2 were due last week. Right, so those... Can you send me an email to remind me? Yeah. That'll help. Thank you. So if there's any questions from any of those things, worksheets 1 or 2, probably not. We've kind of, seems like that stuff is mostly finished up. But if there still is, that's fine. We can go back and look some more. And then, yes, last time we assigned, or on the asynchronous day, we assigned 1 through 16. That has not yet been checked. And then worksheet 4 last time, which again has not been checked. But any and all of that is eligible for questions. So if you have questions on any or all of that, I'm happy to take a few minutes here at the start and do some problems that you weren't sure about or whatever. Okay, nobody? That's all right. So if there are no questions from 4.1, today we're going to talk about section 4.2. And that's going to be the last section we're going to cover in chapter 4. We'll only need one day to do this because there's not a lot of new content here. There's just kind of some application. So I want to start with just a little bit of vocab. And I want to start here with like 2 terms. But these 2 terms I'm going to define with a picture. Okay? So let's say we have 2 people. One person's on the ground and one person's at some elevated position. And let's say each of these people are just kind of looking straight ahead to start. So it's like their line of sight. Now let's say the person on the bottom looks up at the person at the top. This angle formed here, we call this an angle of elevation. Because what are you doing with your head to look up at the person? You're elevating your line of sight, right? And then if you're the person on the top, and you tilt your head down to look at the person below, we call that guy the angle of depression. Because again, what are you doing with your eyes? You're tilting your head downward. So we're calling that an angle of depression. The most common mistake that students will make is they put the angle of depression there. Again, you have to think about the angle of elevation, the angle of depression are formed by your line of sight and then what you're tilting up or down to get to. So it's always between the line of sight, the horizontal, and then whatever you're tilting up and down to get to. Hello. Thank you. You're welcome. Blaine, can you do me a favor and bring this down to Nico in study hall? Yeah, he's just in Mr. Emmerich's room. Thank you. Yeah. Any questions on this vocab here? Notice I didn't define any of this with words, right? Because how are we going to use this vocab? We're going to use it to draw a picture. right? So the picture is enough for us for vocab. So far, so good? That's it for new content. Oh, all right. Very good. So let's do some examples of how we're going to use this. In story problems. So this story problem reads, Christy is looking up at the Fisher Building in downtown Detroit. She is standing 200 feet from the base of the building and finds the angle of elevation to the top of the spire to measure 66 degrees. Thank you.
Yeah.
How tall is the Fisher Building? So, in general, for all these story problems that we're going to look at today, we should begin by drawing a picture, a well-labeled picture of the situation. Everybody okay with that? Okay.
Did we not already do this?
Not yet.
Or was that last year?
Maybe last year. So I'm going to put a K there at that point for Christy. And I'll label that S for the spire. We know that we are 200 feet from the base of the building. We're asking for how tall is the building, so I'm going to label that X. And then we say the angle of elevation from Christie to the top of the spire is 66 degrees. Where should the 66 go?
Okay.
In between K and the horizontal, right? Now, there's one other assumption that we should make in this picture. Anybody see what it should be?
It's 24.
Okay, you could label the other angle as 24. That's true, because those two angles should be complementary. But why would they have to be complementary? Because it's a 90-degree angle. How are we able to assume that? Buildings are perpendicular to the ground, yeah. Unless you're in Italy and looking at the Leaning Tower of Pisa, we can assume that buildings, trees, people are perpendicular to the ground. Everybody's okay with that? So, what have we just created? This is a right triangle trig problem, right? It's just SOHCAHTOA. Everybody good? So if we're using SOHCAHTOA, which sine, cosine, or tangent should we use? So relative to this angle, we know this side, which side is that? Opposite, adjacent, or hypotenuse? Okay. And we want to know this side. Which side is that? Opposite, adjacent, or hypotenuse? Opposite. So which trig function involves opposite and adjacent? TOA, that's tangent. So write tan of 66 equals opposite over adjacent. Everybody okay here? This equation that we have is a proportion because we can think of it as two fractions equal to one another. All of you that have been so desperate to cross multiply, this is the situation where you can use cross multiplication to solve a proportion. So x times 1 is x, and then tan 66 times 200, I'm just going to write as 200 times tan 66. And now it's going to be calculator time. Before I go and start typing this into my calculator, though, what do I need to be aware of? Excellent. I need to be aware of the mode of my calculator. This problem, the angles are measured in which one, degrees or radians? Degrees, because it said literally 66 degrees. To type this into my calculator, what mode does my calculator need to be in? Degrees. What have we been using up until this point in this chapter? Radian. What are you going to have to be extra careful about on the test? switching back and forth between degree and radian mode appropriately. Okay, I will remind you again on the test day, but I want to point this out to you now in case you wanted, that's something that you'd want to put on your note card as you're building your note cards already. So I get 449.2. And the unit there should be feet because the 200 was in feet. How do you guys feel on that? Is that okay? No big deal. Right, let's do another then. Jane has climbed a tree and is looking down at her friend Mary. She has climbed 17 feet into the air, and the angle of depression to Mary is 49 degrees. How far is Mary standing from the base of the tree? What should we begin by doing? Drawing a picture. So there's Jane at the top of the tree. There's her friend Mary. We'll assume that the tree is perpendicular to the ground. We're told she's 17 feet in the air. And the angle of depression to Mary is 49. Where do I put the 49? So you want to put it right here. That is incorrect.
Wait, what was the question?
So where should I put the angle 49? So it's an angle of depression. So Jane's line of sight is here.
Yeah, so she's looking down.
And she's looking down. The angle 49 should go there. So what should go in the place where we did have the 49? 41. Or we could write the 49 down here. Why can we write the 49 down there? Yeah, well, there's a theorem from geometry. Does anyone remember what that geometry theorem says? What it's called? So they're alternate interior angles. So if you have two parallel lines, that would be Jane's line of sight and Mary's line of sight that are cut by a transversal. Alternate interior angles are congruent. So you could use that to label angle M as 49, or you could use the fact that those two angles at J need to be complementary and label that angle at J to be 41. Either one will get you the correct answer. Is that okay with everybody? Okay. What we're asking is now, how far is Mary standing from the base of the tree? So that's our side X. So now we're going to pick an angle. Which angle would you like to use? The 49 or the 50, or the 49 or the 41? Does it matter? Of course it doesn't matter. Let's pick one though. Which one should we use? 49. That's fine. Okay. Relative to the 49, the side we know is opposite, adjacent, or hypotenuse. Opposite. And the side we want to know is that opposite, adjacent, or hypotenuse. Adjacent. So which trig function should we use? Tangent. So we can say tan of 49 equals opposite over adjacent. And now we can do our cross multiplication. So I have x times tan 49 equals 17 times 1. To get the x by itself, then what do I need to do? Excellent. Divide by tan 49. And then it's just calculator time. Again, reminder, what mode should my calculator be in for this problem? Degrees, because the angles given in the problem are measured in degrees. So I have 14.8. And I think the units here were feet, so that should be in feet. Yes, Ellie. Sure. All right. I think I got, yep, just one more example. You guys ready for this? This one's a toughie. Claude and Simone are riding bicycles in Paris. At one point, they look up and measure the angle of elevation to the top of the Eiffel Tower to be 32 degrees. When they pedal 100 meters closer to the tower, because we're in Europe, we're going to use meters here, the angle of elevation changes to 37.5 degrees. How tall do they estimate the Eiffel Tower to be? So let's draw our picture. I'll make that E for Eiffel Tower. I'll call that P1 and P2 for the first point and the second point. At the first point, we know that our angle of elevation was measured to be 32 degrees. And then we pedaled 100 meters closer to the tower. And we measured our angle of elevation a second time. And now it's 37.5 degrees. And we're looking for how tall that Eiffel Tower is. Is everybody okay with how we've constructed this picture? Does that match what the words were saying? Sometimes that's the hardest part, is getting the picture, right? All right. So when you look at this problem, what do you want to do here? Because it doesn't seem like we have enough information, right? Is there any right triangle where we know one angle and two sides? There's not. However, if I look at this, I see two triangles that are similar. Who remembers what similar triangles are from geometry? We say that two triangles are similar if all their angle measures are congruent and all of their side lengths are proportional. Actually, you know what? We don't even need similar triangles. Forget it. We don't need to use that. Here's what I'm going to do. This will be easier. I see one right triangle here. I'm going to redraw that below. And now this side, I'm going to call, well, I know part of it's 100, but we don't know the other part. I'm going to call that part y. So this side should be 100 plus y. Is everybody okay with how I constructed that right triangle? I'm then going to draw this right triangle. Again, I'm going to draw that separately below. So that right triangle looks like that. we feel okay there? So if I look at this first triangle, relative to this angle 32, the two sides we're concerned with are opposite and adjacent. So I can write tan 32 equals opposite over adjacent. Similarly, in triangle 2, relative to angle 37.5, I know that I have opposite and adjacent that I'm concerned with. So once again, I can say tangent of 37.5 equals opposite over adjacent. What I've just done is created a system of two equations with two unknowns. Right? My first equation, tan 32 equals x over 100 plus y. And my second equation, tan 37.5 equals x over y. Both of these two equations must be true at the same time because they come from the exact same picture. Everybody okay with that? So what we can do is we can treat this as a system of two equations. This was a type of problem you solved last year in your Algebra 2 class. You would have discussed at least 3 methods for solving a system of two equations. Can someone tell me one of those methods that you could have used to solve a system of two equations? It's at least 3 that you would have talked about. Ava. Elimination was one of them. Very good. What else? At least 2 more. Delaney? Okay, so that would be substitution. If you can isolate a variable, then you can set them equal to each other. That's called substitution. That's 2. For sure, there's one more that you would have talked about. You probably didn't spend a lot, but graphing. You could graph the two equations and then find the intersection. And then how many did you guys talk about matrices last year? You can solve a matrix equation or do some other matrix methods like Gaussian elimination to solve this system as well. The one that we're going to use is going to be substitution. Everybody okay there? Now, all of these are possible. It's just a question of like, how messy do you want this to get? I think the minimal amount of mess in a situation like this is going to be substitution. So as Delaney had suggested, let's start by trying to get these two variables equal to this, or these two equations equal to the same thing, so that we can just make a substitution, one equal to the other. So if I take a look at equation 1, maybe I'll call them A and B. That'll be less confusing, right? We have enough numbers rattling around here. Again, let's think about this as a proportion. So we can cross multiply. So I can say x equals tan 32 times the quantity 100 plus y. do the same thing with equation B. So we have x equals y times tan 37.5. At this point, notice that both of these equations are equal to x. What does that allow us to do?
Set them equal.
Yes, very good. We can now set them equal to each other. And now I have how many variables in my equation? Just one kind of variable, right? Just y is the only kind of variable I have. That's an equation that we can solve. So I'm going to start by trying to get the y's on one side. So let's distribute that tan 32 through. And then I'm going to subtract y times tan 32 from both sides so that I have y's on the same side. So far, so good. What do you notice on that right-hand side? I have y's in two different places, although they're both just y's. How can I get those y's into one place instead of two separate places?
Subtract.
What do you mean by subtract?
Like y tan 32. No, that's two. That'd be like 5.5.
So what you'd be saying then is that like tan of A plus tan of B is equal to tan of A plus B. That's what you're saying, right? Is that this would be true?
Not true.
It's not true, because what you'd be saying is then that tangent distributes, right? Remember last time we talked about distributing functions that nothing distributes other than multiplication and division, at least that you know about? So that's not it. Yes, Jake. Sure. What if I notice that both terms on the right-hand side have a factor of y in it? What? Well, kind of, but let's factor that y off. What would I have left if I factor a y off there? I'd have tan 37.5 and then minus tan 32. Does that feel okay with what we did there? Because yeah, nor they're like terms, right? So how do I add or subtract like terms? I just add or subtract their coefficients, which is basically what we've written there, right? The tan 37.5 and tan 32 are the coefficients on our variables. Does that feel okay? And now to get that y by itself, what should I do as my final step? I want to get the y by itself. What's happening to the y? What operation? Which is distribution is multiplication. How do we undo multiplication? Divide. What should I divide both sides by? Tan 37.5 minus tan 32. Right? The thing that we're multiplying to the y. Colin, will you grab the door for me? Thanks, bud. So, into my calculator, this is what we're typing in. Now, this is a sort of problem that screams, please use the fraction command on your calculator. So I'm going to press alpha, then y equals, and pick option 1. So I can type my equation now in exactly like it looks like on my sheet of paper. If you don't use that fraction command, you're going to need like a boatload of parentheses. And trust me when I tell you this, this is way easier to tell if you've typed it in correctly because literally it just has to look like it does on your sheet of paper. So if I press enter, I get that y is 438 point something somethings, hold on, 6, and that should be meters. Did that answer the question, though? What were we asked in the question? Let's go back and look real quick. We're looking for the height of the Eiffel Tower. That's x.
So we have 5, whatever.
So we have to figure out what y is, right? What will I do? Right, I'm sorry, what do we have to figure out what x is? Yeah, I'm going to plug in the y into one of these equations to solve for x. I would pick the second one because, well, like it's simpler, right? So we'll just say then tan 37.5 equals 438.6 over x. Oh no, it was x over y, right? Was my equation? Sorry. Okay. So if I get the x by itself, I'll multiply both sides by 438.6. And it's calculator time, my homies. So take that answer that I just got and multiply it by tan 37.5. And we'd say the Eiffel Tower must be about 336.6 meters. Ava. How'd I do what in the what?
Like the y equals.
The y equals.
For like,
How did I type this into my calculator? So I pressed alpha, y equals, and then picked option 1. That gets the horizontal fraction bar in there. And then I just typed it in just like it looks like on my paper from there. Sure thing. All right. That's the worst case scenario for a problem for you guys, is something like this that involves having to solve a system of equations. So at this point, we're going to assign worksheet 3 which is 6 of these story problems. And we're going to assign problems 17 to 23. Let's summarize what's due when, though, right?
Yeah.
So Sunday, this Sunday is the 19th. So here we're going to have worksheet 4. We're going to have 1 through 16 and the Delta Math. The Sunday after, we're going to have worksheet 3 and then numbers 17 to 23 and the review. But reminder, what's due on Friday? You guys okay with the due dates on things? Clear? So what's due when?
Half sheet is due Friday.
Yeah, half sheet due Friday.
Gotcha.
Mm-hmm.
We got 40 numbers.
And you got 45 minutes right now, and you'll have the class on Friday. Sound good? Okay. As a suggestion to you, I would include a problem like this example 9, or a problem similar to like problem 6 from the worksheet, or even from the review. What is there on the review? Like question 7 from the review, something like this where it has the solving the system involved. That's, I think, definitively the most complicated thing we do this chapter. I'd want an example of that on my note card.
End of the week, and that's like the last time you do it.
What's the semester?
The last,
Yeah.
well, let's see, our exam day would be
Is it right there? That's,
December
so
18th.
the last time you could take it.
I don't know, you could ask me. What are we biologying?
Enzymes.
What enzymes?
No, the final.
Yeah.
Oh, yeah. Yeah.
Are we gonna get a half
Like-
like for our final
Uh,
exam? Through evolution.
do you want to talk about the final exam for a moment?
Sure.
We can do that.
Wait, what? No.
So typically what I do for the final exam is I'm going to give you a review packet. The review packet would be due the last day of class, formal class for the semester. If you turn in the review packet on that, by that last day, I'll give you extra credit on your exam for completing it. And I will let you use the review packet on your exam.
Oh my god, okay.
So better than a half sheet, right?
Yeah, that's definitely better than half sheet.
Okay.
We write other stuff.
You can write yourself instructions on how to do the problems on there, as long as it's pertinent to how you do the problem that you're writing about. I think that is perfectly reasonable. Yes. Yeah, you would not need to ever provide a unit circle for yourself in this class. Although if you plan on taking a calculus class at some point, you may want to memorize that, but not for this year.
Wait, Mr. Do you have a photographic memory? Mr. Smith was talking.
I have like an excellent contextual memory. So like stuff that's related to something else is very easy for me to remember. But I can't, like, if you just give me a list of words to remember with no context to them, that's not easy.
So if I show you my ID number, you would not be able to remember.
No. But if, like, we talk about, you know, like the way I try to learn in school would be, how is this related to things I already know? So like I try to build a mental file cabinet where like all the related things have like links to one another. So it's not like a standalone thing I'm memorizing, it's a natural extension of something else I already know. Because some of us, our brains look like a file cabinet, some of us, our brains look like a pile of papers just dumped in a box. I try to, as I'm learning something, try to build myself like the scaffold for the file cabinet so that things are related together so I can see the interactions. And while that makes things maybe very difficult in the beginning, as you're trying to like build those connections, by the time you get to the end, everything is much, much easier because it's not just like rote memorized anymore. It's just like it's all contextual and makes sense because it fits with everything else. If I found that if I approach my learning that way, it doesn't go away either, like it sticks. So that's what I would how I'd explain my memory of what I'm trying to do when I'm learning something. It's not just like everything sticks, but if it has a place, it sticks. So like things like birthdays are hard to remember because there's no stick to it. But like, you know, your mathematics theorems are easy for me to remember because they have like a natural extension of something else. Like it makes sense that this logically has to be true. And because I can see the obvious truth in it, it's easy to remember. You know, and the same thing would be true for most of your like rules-based hard sciences. Your chemistry's very, very easy because all of it is like 2 or 3 principles and just natural extensions of those principles. So like that stuff was always easy for me. I'm gonna pause this now. So if you look on our My Notre Dame page, if you look at the bottom of that, under announcements, I have something called surveys. There's 12 links to 12 Google surveys. They're short. They're like 2 or 3 questions a piece. If you complete all 12 of these, I'll give you 1% extra credit on the next test.
Wait, you do how many?
All 12. If the entire class does all 12, I'll give you 2%. Then you're already done. Yeah.
We're doing these surveys. They're not.
That's great.
How do I show you?
I have access to the data, so it records the email addresses. I believe you. I don't think you'd lie to me.
My friends already.
Some of you that are seniors may have already completed this in your CT room. Yeah, that's excellent. I thank Ms. Hall. But yeah, if you could finish the rest of them. Sure. You're welcome.
Here's one too.
Can I go and I'll come back and do all the surveys?
Thank you. Sure.
What do you want?
Oreos. Sweet or salty? Tell her sweet or salty.
Pretzels. Pretzels.
What do they have pretzels?
Salty then. Just get him something else salty.
Yeah, but like plain chips.
Okay.
Not much of a flavor.
You're fine.
All right.
Fine, I'll get you.
Chip flavors.
Potato.
Flavor, but not chip flavors.
Potato chip.
Yeah.
Give me something. Say, oh my god.
Or Dorito.
She's getting me something.
Doritos are definitely flavored. It's like flavor country right there.
Like